Okay, today we'll be looking at some more multiplication properties of exponents. Real quick, I want you to go to the bottom and review what we did last time when we multiplied with the same base. So for instance, let's say I have x squared times x to the fifth. Remember, you keep the part that they have the same, so I'm going to keep the base. Multiplication means you add the exponent, so it would be x to the seventh. So the rule is simply you keep the base, add exponents. And remember, sometimes you have coefficients. So let's say I have the following: 2x cubed times 3x to the sixth. 2 times 3 is 6, so we multiply coefficients. X have the same base, so we keep the base, add our exponents, so our answer here would be 6x to the 9. So that was a review from 8-3. Okay, so we're going to use that rule, and then we're going to add one that they now call power to a power. So if I look here, this is a power to a power because it's the third power raised to the sixth power. On power to a power, you keep the base of x, and you multiply the exponents. 3 times 6 gives me 18. And this one again is power to a power, so it's negative 2 to the fifth. So if I look here, that gives me b to the negative 10th. We are never done if our exponent is a negative exponent, so you always need to write exponents with positive. So if you can recall back, that means it's in the incorrect position. Remember, we call it move it, lose it. So I need to move this and lose the negative. So I'm going to move it to the denominator, lose the negative. My final answer here would be 1 over b to the 10th. Example 2 then, this is just an expression now. I'm going to remove the parentheses first by doing power to a power rule. So I have c to the fifth, stay c to the fifth. C to the 3 times negative 2 is negative 6. This is now multiplication, so I can use my multiplication rule. They both have a base of c. I add the exponents and I get a negative 1. I'm not completely done because I have an exponent of a negative. So that means it's in the wrong position, so I need to move it, lose it. So I could write it as 1 over c to the first. C to the first is simply just c, so I could also write the answer as 1 over c. So there we had to do power of a power to remove our parentheses. And then we have multiplication. I can keep going because they have the same base. So anytime they have anything alike, I need to keep going to finish it out. Multiplication means I keep the base that is the same, and I add my exponents. Here I wasn't completed because I got a negative exponent, so I move it, lose it, and I ended up with my final answer. Example 3 is simplifying a product raised to a power. So here, this whole thing is squared. So I got to make sure I get that to every single term on the inside. So I would get 2 squared, x to the 4 times 2 is 8. Well, 2 squared, I need to go ahead and keep simplifying. 2 squared is 4, x to the 8. I am now completely done. If I look at the next one, I have negative 2 that needs to be multiplied for power to power to remove my parentheses to both of these terms. So I get 6 to the negative second, y to the negative 6. They both have negative exponents, so I need to move and lose them. So it'd be 1 over 6 squared, y to the 6. 6 squared then can be simplified to 36. So my final answer would be y over 36, y to the 6th. Okay, example number 4 then. Basically, it's just more complicated problems with more power to power, and then also we have multiplying with the same base. So if I look here, I have power to power, so I end up with x to the negative 4. This 4 has to be spread to every term in here, so that's 3 things we have to multiply the exponents by. So I have 3 to the 4th, x to the 4th, y to the 8th. because you multiply exponents on power to a power. Now I can combine anything that's alike. Well, I'm going to write my coefficient first, so my coefficient would be 3 to the 4th. So 3 to the 4th power is going to give me 81. And if you have to, you can use your calculator to get you that. These both have the same bases of x. So I'm going to keep that base. Multiplication means I add the exponents. Negative 4 plus 4 is 0. And y to the 8th doesn't have anything like it, so I keep it as y to the 8th. Then you must remember anything to the 0th power equals 1. So 81 times 1 gives me simply 81. And then y to the 8th stays y to the 8th. So my answer is 81 y to the 8th. Okay, on my next one, again, you have to spread this to all of them, so I end up with 6 cubed, m cubed, n cubed, times, and if you want to put your times symbol in there, you can, 5 squared m to the negative 6. And now I'm going to combine anything or simplify anything I can. 6 cubed, I get as 216. M cubed, n cubed, 5 squared I know is 25, n to the negative 6. Now I'm going to combine everything that's alike. So I'm going to multiply my coefficients. 216 times 25 gives me 5,400. M cubed has the same base as n to the negative 6. So I keep the base, add my exponent, so it gives me n to the negative 3rd. N cubed does not have anything else like it, so I leave it as n cubed. I'm not done here because I have a negative exponent. So remember to move the part with just the negative exponent. I move it, lose it. So the 5,400 and the n cubed stay in the numerator because neither of those have a negative exponent. M to the negative 3rd, I'm going to move it and lose it. So my final answer is 5,400 n cubed over m cubed. Example 5, our real world problem solving here. All objects, even resting ones, contain energy. A raisin has a mass of 10 to the negative 3rd kilograms. The expression 10 to the negative 3rd times the quantity 3 times 10 to the 8th squared describes the amount of resting energy in joules the raisin contains. Simplify the expression. So they just want us to simplify this. First of all, we remove the parentheses by completing power to a power. So to remove the parentheses, 3 squared times 10 to the 8th squared, 8 times 2 is 16. I know 3 squared is 9 times the bases of 10 are the same. I'm going to keep the base of 10. Multiplication means I add the exponent, so it's going to be 9 times 10 to the 13th. 9 times 10 to the 13th joules of resting energy in a raisin. Okay, when we look at our exponent rules, we already filled out multiplying with the same base. Basically, it's keep the base, add the exponents. Our new one was when we had power to a power. So an example of that, let's say we have a cubed squared. Keep the base, multiply the exponents. Okay, so our rule is keep the base, multiply exponents. So on both of them, we're keeping the base. Go ahead and complete your quick checks, and then look at the schedule for your assignment.